Alright, welcome to Inverse Variation Level 1. Now we're going to start with just some very easy examples of what is inverse variation and what is its kind of opposite, direct variation. So, number 1 says this: given y varies directly with x, write a specific equation where x equals 8 and y equals 3. So in this video we're going to make a real distinction between general cases and specific cases. Alright, well, this one says varies directly, because in order to know what inverse is, we also have to know what direct variation is. And direct variation has this general form of y equals k x. And what are we really saying here? Well, we're saying that if you take any number x and you multiply it by k, then you're going to get y. Well, here they give us the specific x and they give us the specific y. So let's go ahead and plug these things in. So where it says y equals 3, in place of this y, I'm going to write 3 is equal to, and here, when you look through this problem, we don't see the letter k, so I'll just write the letter k as the letter k, but we do see this letter x. Now remember, when plugging in or substituting in a value into a variable, go ahead and use parentheses if it's next to anything else. In this case, since it's next to the k, I'll put my parentheses. And we see here that x is actually equal to 8. So, if I were to look at a very specific example, we're saying that when y equals 3, we can write this as 3 equals, and then I'm actually going to switch the order here just as we typically do, 3 equals 8k. Now notice that we don't know what k is, and that's actually going to be this kind of the goal of our level 2 video, but right now it's just all about how can you set this up correctly. Alright, let's go ahead and move on to our second example. Okay, here we are in our second example, and given y varies inversely with x, write a specific equation where x equals -10 and y equals 6. Now notice, instead of saying that it varies directly, it's saying that it varies inversely. And this means we actually need an entirely new equation. So our new equation is going to be y equals k over x. Now remember, when you see a fraction, that actually means to divide. So when y varies directly with x, we do x times k, and whenever y varies inversely with x, we're actually doing k divided by x. That order is very important. Now let's go ahead and plug in the things we know. So I see that y right here, y is going to be 6 in this specific case, is equal to, and right here, we still don't know what k is, which is what you're going to learn about in our next video, but we call it the constant of proportionality, all divided by x, which is in this case -10. Now this is essentially good enough. However, I'm going to rewrite this slightly because I want you to understand that whenever you have a fraction and one term is negative, we can actually always pull that negative out in front of the fraction, and it just makes this whole thing nicer and neater and easier to work with. So the best way that I'd like for you to write this is that when y varies inversely with x, we're going to write this as 6 equals -k over 10. Alright? Let's go ahead and move on to our third example. Okay, here we have our third example, and if you'll notice, now we have word problems. So, as you eat more food, the number of calories you consume increase. How does the quantity of food you consume vary with the number of calories consumed? So in this question, we're essentially asking, are we going to be using inverse or direct variation? So let me kind of talk about this. Let's label our two things. We have the amount of food you consume and the number of calories as a result. Let's go ahead and write food. And then let's also over here, let's write calories. Now there's a very simple way to figure this out. So let's just do this. Food. As we eat more, ask yourself what happens to the calories. Do the number of calories increase or do they decrease? Well, as you eat more food, the number of calories that you consume is also going to increase. So as this one increases and this one increases, this is an example of direct variation. Okay, so what we're going to say right here is food is the input, it's what's happening first, and then calories is going to be our output. Let's see right here. Alright. And we know that our input is typically going to be our x value, and our output is typically going to be our y value. So remember we said that as food goes up, calories go up. This is an example of direct variation. So direct variation will be y equals k x. Now, let's just go ahead and take these labels and plug them in. So what is y? It was our output, or aka our calories. So we can simply write it like this. Calories is equal to, now I do apologize for writing so slow, I have a little bit of a stylus issue, k times, in this case we'll go ahead and write food. So if we want to simply write this as a very generalized formula, all we're going to do is just plug in these labels, and I want you to understand that calories varies inversely with food, and so essentially you're just multiplying food by some constant k. Alright, and this is the answer that I'm looking for in this specific level. Alright, let's go on to our final example. Okay, and here we are in our fourth and final example. So, you have a summer job, and after a very large paycheck, you want to take some friends out to eat. So you're feeling very, very generous. You budget $100 for everyone's meal, and I should have the word here total, but just $100 for just this one meal, and one of your friends suggests bringing another friend. And once he invites that friend, well, that new friend suggests bringing another, and this series of recommendations continues. How does the number of friends you bring vary with the amount of money per person? So I kind of want you to think about it this way. We have this $100, and let's just look at a very, very, very specific case. Let's say you had $100, and let's say you actually kind of put a stop to the friends inviting friends after the fourth person was committed. So what is $100 divided by 4? Well, that would be $25 per person. So for $25 a person, you can still go out and get a pretty relatively nice meal. But what if you didn't stop at $100, or I'm sorry, at 4 people? What if you took that same $100, apologize for these stylish issues once more, and let's say that like a friend suggests a friend, who suggests another friend, who suggests another friend, and now you are taking out 10 people. So what's 100 divided by 10? Well, that's going to be $10 per person. So think about it this way. What's going on here? We have the cost per person, or you could say the amount per person, but let's just go cost. And then we also have the amount of people. And our question is, does the cost per person vary directly or inversely with the number of people that we bring? Well, we see that as the number of people that we bring goes up, the cost that we can spend per person, or the amount that we can spend per person, is going down. So as one number increases, the other number decreases. And this is actually the perfect example for inverse variation. And so, how are we going to write this? Well, we see that cost is essentially the output, so that's going to be our y. And we see that people is the input, that's going to be our x. And so we can write it as such. Since it is inverse variation, that's going to be y equals k over x. And here we write it as simply as this. The cost is equal to some constant k, some proportion that we don't know yet, over x, the number of people. And so this is how we would write this situation out as inverse variation. Okie doke. Cost is equal to K over people. Alright, well I hope these help you out in setting up these word problems and modeling them. And we'll see you in our level 2 video. Thank you.